Hi students, this week we're going to be going over measures of variability. So last week we talked about measures of central tendency, which included mode, median, and mean. And as a reminder, this is one number that represents the whole data set. But sometimes we want to know how scores vary or differ from the center or the norm. So sometimes central tendency doesn't help tell us the whole story. So as an example, Hawaii and Phoenix have the same average or the same mean temperature of 75. However, temperatures in Hawaii usually range from 70 to 80, while temperatures in Phoenix usually range from 40 to 100. So there's more variance from the center in Phoenix because there's a wider range here than there is here. So this section, or this week's lesson, is about different measures of variance, or the spread of numbers. So there's a larger spread here than there is here. So here's our agenda for today. We're going to talk about 4 different types of measures of variability: range, interquartile range, deviation from the mean, and then variance and standard deviation. So let's first talk about the range. This is the difference between the highest and the lowest score in a distribution. So for example, going back to that Hawaii, the lowest tip in Hawaii was 65 and the highest was 89. So the range would be 89 minus 65 is 24. Go ahead and calculate Phoenix. Alrighty, the range is 65 for Phoenix, so that's quite different in Phoenix than it is in Hawaii. So while their average was the same, which was a measure of central tendency, this range number gives us a little bit more information, which is helpful to know. All right, next type of measure. Let's talk about the interquartile range. So sometimes it's nice to be able to explain more than just the top and the bottom number, such as we did here. We were just looking at the highest and the lowest number. Sometimes it's nice to be able to explain the scores in quarters, in the 25, 50, and 75%. So thus, if we know a score is in the first quartile, we know that 25% of cases fall beneath it. So you can have scores here, scores here, scores here, and scores here. So it's nice to know where the scores are within this interquartile range. So you can find the interquartile range in just 3 steps. So let's go ahead and watch this video to go over how to do that.
Welcome to My Secret Math Tutor. In this example, we're going to find the interquartile range. Now, what the interquartile range is it's basically the range of the middle 50% of all of our data. Alright? So the way we're going to work this is first we're going to organize all of our data from lowest to highest. Then we're going to find the median of the upper half and the median of the lower half. And then we're going to subtract the two in order to find that range. Okay? So let's see how this process works out. So first I'm going to take all of this data and just write it out from lowest to highest. This will just allow me to get a better visual sense of where the median of the upper half and lower half fall. There we go. There's all of our data. Now you'll notice that I have an odd number of data points. This actually makes a little bit of a difference. It means that when I go to find the median of the upper half and the median of the lower half, I first have to find the median of the entire set of data. So imagine working from both ends to find that middle point. And it looks like it's 10. Now since we have an odd number of data points here, when I go to find the median of the lower half and the upper half, I'm not going to include the 10. There we go. So now let's find the median of this lower half and the median of the upper half. Let's say I got 1, 2, 3, 4, 5, 6, 7 values here. The median would be the 7. Let's see, for the upper half, looks like the median would be the 15. Now some books actually give these names. They call them Q1 and Q3. That's okay, because what we're basically going to do is now take Q3 and subtract Q1. So 15 minus the 7. That will give us an answer of 8, and that 8 happens to be our interquartile range. Now this example works out slightly different if you have an even number of data points, Basically, you would find the median and then find your lower median and upper median and subtract the two from there. If you'd like to see some more videos, please visit mysecretmathtutor.com.
Alrighty, so here's a practice question for you to be able to calculate that interquartile range on your own. So if you want to press pause and go through the steps that the man on the video just did, and then when you're ready, press play and we'll have that answer for you. So go ahead and press pause now. Alrighty, and so here is the answer from that last slide. And 16 was that interquartile range. And that was that 92 minus the 76. Alrighty, now let's see it on a normal distribution. So we looked at this a little bit last week. You might remember that if it's a completely normal distribution, then the mean, median, and mode is all right here. So what we did was we have all of our scores listed out here, and then we're divided up. We've divided that normal distribution up into 25, 25, 25, and 25. We have our the 75th percentile and the 25 percentile, and then we've minused right here to find that interquartile range. So that's just another way to kind of be able to visualize how that interquartile range plays into this whole normal distribution idea. So the interquartile range is important because it tells us the spread of that middle 50% right here. It describes those that are in the middle. And as we talked about in a previous class, a lot of data does tend to group towards the middle, so it's helpful to be able to know what that middle 50% is. All right, next one. This is another type of calculation that we can do. We can use we can calculate the deviation from the mean. So this is the difference between any given score on a distribution and the mean or the average. So this is some raw data that we have. So find the mean of the raw data. Let's go ahead and do that. So it's just 84. So we've added up these and we've divided by n. N is the number here that we have. And then subtract the mean from any of the raw scores. So let's say 96 we just want to choose. And then we subtract 84 from 96, and then we get 12. So that's 12 is our deviation from the mean for that particular score of 96. And again, that n here is just the number that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alrighty, so let's see it on a normal distribution. So this is that one score that we chose to look at, this 96, is all the way up here. So it's in that 75th percentile. So it's pretty, it's not in the norm. Where a lot of the normal scores hang out is here in that middle. Instead, it's really up here, which is quite unique. And this one is a little bit negatively skewed. So you can see the mean in the median and the mode are not the exact same. The mean is over here, a little bit to the left of that median. So it is a little bit of a negatively skewed distribution. It's not quite normal, but it's kind of helpful to think about when you're looking at different distributions. It's helpful to think about, what the shape of that distribution looks like. So that's all fine and good, but this is not extremely useful because we're only looking at one particular score. So, yes, deviation from the mean only explains how one score deviates or varies from the mean. So it's not very helpful in analyzing a full data set. So a lot of times we want to know how all the scores vary from the mean. And that leads us to what's called standard deviation from the mean. So before we called it deviation from the mean because we were just looking at one score. Now that we're looking at more than one score, we call it the standard deviation from the mean. So we basically just went from goose to geese. And then also what we're going to be calculating as well is we're going to be calculating variance. And so earlier in the deviation from the mean, we talked about a score varying. Now we call it variance. So similar to that goose to geese. So this is how much on average all the scores vary from the mean. So now let's go ahead and cover both the standard deviation and variance, and we'll talk a little bit more about what those are. So first, before we go into this calculation, because it's a 7-step calculation, sometimes I like to think about, okay, what does this mean? Because sometimes, you can, the calculation that we're about to do is not difficult, and we do it step by step, but sometimes it's you can get so engrossed in the calculation, you're like, wait, what am I doing again? So sometimes it's nice to think, okay, what does vary mean? What does deviate mean? So just think for a second, what does it mean when someone says, oh, that varies? It depends on different things. It changes. That's what it means, right? When you're just in normal conversation and someone says, well, that varies, it means that it depends or it changes. So what does it mean when someone says, don't deviate from the instructions? It says, don't depart from the usual. So it's helpful to kind of understand the normal language behind them, what varies and deviate mean. All right, so let's go ahead and calculate that variance and standard deviation, and it can be calculated in 7 steps, so we're going to go through that now. So let's say we have raw scores representing the age at which first marriage for a sample of 25 adults. So 25 is our N. This is our amount of adults here that we have. And this is the age at which they were first married. So this is our raw data. So the first step in calculating variance and standard deviation is just to get organized. So first, arrange all the 25 raw data scores into a table. The next step is to calculate the mean. So add up all the scores, all these X's, and divide by the N, which is 25. So when we added all of these up, it was 575. Divided by 25 is 23. And then what you do is you make a column for the mean. So go ahead and add additional column and then just put 23 down all of the different rows. Step 3, X minus mean. So 31 minus 23 is 8. 30 minus 23 is 7, etc. Do that for all of them. Next step, step 4, check your math. So this is a 7-step process. So let's not go ahead and mess up with step 3. So it's good to be able to take a step to actually make sure that you're doing the steps correctly. So if you've added all of these up correctly, right here, if you've added them all correctly this way, and then you add them all up this way, it has to equal 0. So this should always add up to 0. So if it's not adding up to 0 right now, take a second, recheck your math, and then do it again, because this should definitely add up to 0. So step 5, square column C to get to column D. So you're just squaring. 8 squared is 64. 7 squared is 49. And to square something just means to times it by itself. So 8 times 8 is 64. 7 times 7 is 49, etc. Now, when you get to these negative numbers down here, when you put -1 times -1 in your calculator is probably going to give you a -1 as well. But remember that when you square something, it can't be negative. So just go ahead and make that a positive number if that's what your calculator is giving you. So go ahead and do that with all of them. Next, add up that column D. So go ahead and now that you have all of these added, or calculated, excuse me, go ahead and add that up. Okay, we have that 364. And then step 7, we're finishing the formula. So I don't really like talking in formulas. I don't think it's super helpful. I like talking in steps. But what we have been doing is a formula. So now we're just going to go ahead and finish it up. So we're doing the 364, which was the number that we calculated up here, divided by the N, which was 25 adults. And that gives us the variance. And our variance is 14.56. Now, we'll talk about it in a second, but variance isn't a very helpful number. It doesn't really tell us a whole lot. But what does tell us is standard deviation. That's a helpful number. And how you get from variance to standard deviation, all you do is it's the square root of variance. So the square root of 14.56, just plug it into a calculator, is 3.82. So that is our standard deviation. So for that data set, the numbers which we're interested in are the variance and standard deviation. We just calculated those. And the standard deviation is the one that we are particularly interested in and that's really useful to be able to analyze data. So FYI, what we just did is on the slide before, you just used the N, 25. That's when you're calculating a population standard deviation and variance. When you're calculating a sample standard deviation and variance, you use N minus 1. So you would have done 25 minus 1, so that would have been 24. So you would have done 364 divided by 24. So we're going to talk a little bit about populations versus samples later in the semester, but just know that what we did today, we were calculating the population standard deviation and variance. So check your math. So make sure that what you just did throughout those 7 steps was correct. So this is a great website where you can check your math. What I did was I got our standard deviation, and of course we rounded up here to that 3.82. So this is a great website for you to be able to utilize to be able to check yourself. So yay, you're done. So cheers from Leonardo DiCaprio. So round of applause for you. Good job. Okay, so let's tie what we were doing before to standard deviation and variance a little bit. So I plugged those raw data scores on here. Again, that's at ages, and put it on a normal distribution. And then so had that median and mean. So it's a little bit positively skewed, which we'll see in a second, but I calculated that interquartile range and then the range as well, just so we can kind of see how this is all kind of plugging together. And yes, this is a little bit positively skewed because the mean is to the right of the median, so it's a little bit positively skewed, not that much though. Okay, so let's understand what standard deviation and variance is now. So the reason I wanted to show this is because the interquartile range and standard deviation are similar, but they use different percentages down here. So in standard deviation units, they use these percentages instead: 68%, 95%, 99.7%, or 34%, 13.5, 2.35. So we had them divided up in quarters before, but when you're talking about standard deviation, you're actually using these percentages instead. And this all goes back to something called the empirical rule, which we'll watch a video about what that is. But this is 1 standard deviation unit. This is 2 standard deviation units. This is 3 standard deviation units. So when you are reporting scores and you have a score that's all the way out here, that's plus 3 standard deviation units from that mean, that is really significant. It is not here with the mass of the scores, with where a lot of the scores center around. It's really out here kind of in the tails, or you could have -1 standard deviation, -2, -3 standard deviation. So if you get data that's out here or scores that out here, that's really significant. So this and these increments here that we utilize, these can be utilized on any data set that you have. And these are very commonly known percentages. The empirical rule is very commonly known when you're using statistics in psychology or not psychology. We use these percentages to be able to make sense of our data and be able to describe the data and be able to describe the standard deviation all the time. So I just wanted to explain that while we were talking about it in terms of these percentage increments, now think about it in terms of these different ones here. So standard deviation is how much on average all the scores deviate from the mean in standard deviation units. And there's just plus or minus 3. So 1, 2, 3. And then the variance is how much on average all the scores vary from the mean. And this isn't as helpful to know as the standard deviation. So a lot of times you'll just hear folks talk in standard deviation units and you really won't hear variance, even though you can't calculate standard deviation without calculating variance. But let's go ahead and watch what this empirical rule is, and maybe it'll make a little bit more sense as well. Okay, here we go, finally. Finally loaded.
Normal statistical distribution. The rule states that nearly all of the data will fall within 3 standard deviations of the mean or average. It's broken down into 3 parts. 68% of data falls within 1 standard deviation from the mean. 95% fall within 2 standard deviations. 99.7% fall within 3 standard deviations. Understanding the empirical rule requires a basic understanding of standard deviation. Standard deviation shows how closely groups in a set of data are clustered around the average. When the examples are tightly bunched together, the bell-shaped curve is steep and the standard deviation is small. When the examples are spread apart and the bell curve is flat, the standard deviation is larger. For example, the empirical rule can be applied to the math test scores of 100 students. Their mean score is 70. According to the rule, 68% of the sampled students lie within 1 standard deviation below or above the mean. 95% lie within 2 standard deviations below or above the mean, and 99.7% within 3 standard deviations. The empirical rule is often used in statistics for forecasting, especially when obtaining the actual data is difficult or impossible.
Alrighty, so I hope that helped you a bit. So if you want to see those steps 1 through 7 again, you can watch this video, which I'm about to play here in a second. FYI, I talked about this a few slides ago, but in that steps 1 through 7, we calculated the population standard deviation and variance. So we just use that n. If you're doing a sample, you would do n-1. And the guy here is using the sample standard deviation. It's just a very slight change at the end, but other than that, the steps are all the same. So let's go ahead and watch that now so you can just really get it ingrained in terms of how you calculate standard deviation and variance.
In this tutorial, I'm going to talk about calculating the standard deviation and variance. They're both related. This isn't high definition, so click on 720 before you click the full screen view. The button right there. A typical problem looks like this. The following are the number of jobs a sample of 6 people applied for. Find the mean, the variance, and standard deviation, blah, blah, blah. What you really are interested in are just the numbers and how to calculate the variance and standard deviation. And that's what I'm going to do here. The sample standard deviation is equal to the square root of the sample variance. And these are the symbols I'm going to use. And the first thing I'm going to calculate is the sample variance. The sample variance is this formula right here, and we'll take the square root of that to get the standard deviation. The xi, that's the observations. The x bar, that's the mean. And we'll go through the calculations of these, each one of these two. And n is the sample size. I'm going to make a little table to help me stay organized. I'd recommend that you do the same. I'm going to put in the x, which is my observation. And then I'm going to put a little line, horizontal line, and then I'm going to do an up and down vertical line as well. The next column is the mean. X bar, that's the mean, the sample mean. Put a little vertical line as well. Now I'll just put in all the observations, and that's the same as above, and a line. And I'm going to put a couple more column headings in, and I'll tell you what those mean as we fill them in. But just go ahead and write them in now. And that's the observation minus the mean squared. So I need to calculate the mean, and that's equal to the sum of all my observations divided by the number of observations. So if I add up all my observations, that column right there, that equals 84. Now I take that 84 and I put it right on top of that equation right there, and that's my numerator divided by 6, and that equals my mean, which is 14 jobs. Now I take that 14 and put it right there in that column. And the whole column is going to be filled with 14s. Now the next column over is the observation minus the mean, like 17 minus 14. And of course that is equal to 3. Then I have 15 minus 14, and that's equal to 1. 23 minus 14, that's equal to 9. 7 minus 14, that's a negative 7. 9 minus 14, that's negative 5. 13 minus 14, that's negative 1. If I add up this column, it should always add up to 0. Always 0. That's a good way to check your numbers too. Now my last column, I take the previous column and I square it. So 3 squared is 9. 1 squared is 1. 9 squared is 81. Negative 7 squared is 49. Doesn't matter if we use a negative sign or not, it's 49. Same with 5 squared is 25. Negative 1 squared is 1. I dropped the negative sign, but it's still always positive. Now I add up this column of information, and it's 166. The 166 is actually the numerator of that equation. So that's the same thing. So I can say the sample variance, which I have as s squared, is equal to 166 divided by n minus 1. N is 6, so it's 6 minus 1, which of course is 5. So the sample variance is equal to 33.2. Now if I take that 33.2 and take the square root of that, that's the sample standard deviation, which is equal to, S is equal to 5.76. Now I'll summarize for you. The sample variance is equal to 33.2 jobs squared. Job squared is a unit. Sample standard deviation is equal to 5.76 jobs. The sample mean is equal to 14 jobs. Notice that the standard deviation and sample mean are in the same units, so they can be compared with each other as well. And this has just been a slight review or introduction to calculating the standard deviation.
Alrighty, and so that video in the book uses some symbols. I'm not really fond on a lot of symbols, but these are them if you need to utilize them. And thank you. If you have any questions, please let me know, and I hope you have a great week. Bye.